Hello guys, I'm starting here a new series on circuits and today's today we will talk about the sources of voltage and current and about voltage and current itself. So um, when we start to learn about electronics, there are two main characteristics of a circuit, which are voltage and current. Um, and they can be a little bit hard to understand at first, but basically you can think of voltage, which we represent, so write in black. Voltage as we represent it like the pressure of the water at a pipe, for example. Uh, and we represent the current as the flow of the water in a pipe, right? So if you have a pipe and the fluid is going very fast, this is almost the same as when you have uh, um, an electric circuit, you have lots of current. So the current is the same as flow, whereas the voltage is the same as pressure. For example, there is a component that we will study in the next lessons, which is the capacitor. And the capacitor basically stores charge. So the capacitor acts like a balloon here, and the the water can't escape, but they can start to expand the balloon. So here the voltage will increase, right? Because the balloon will get bigger, and the pressure inside will just grow, right? And we represent voltage in volts and the current in amps, or from the physics ampere. And to represent the sources, because we have voltage sources and current sources, and later we will learn how to basically transform one into the one to another. So voltage sources, we can represent it. The most common way is by doing like this, which means a direct current voltage sources, or a voltage supply. And this is direct current because we represent the smaller the smaller part is the negative part, and the bigger one is the positive terminal, right? Whereas if we are working with alternative current, we don't have a positive terminal and a negative terminal because they are oscillating. So we use this symbol right here, right? So this is for voltage suppliers and or voltage source. And the characteristics of a voltage source is that we don't know, unless we have a resistor or some component that can tell us, we don't know the current that flows through the source, right? But we know what is the voltage across them. It's like it doesn't matter the value of the current that flows through them. We also have that fixed voltage across them. So if we say that we have like Earth here, and we put a 9-volt battery here, we know that it doesn't matter if the voltage source is ideal, that here we will always have 9 volts, because here we have 0 volts, and if we go across this, we have here plus 9 volts, so here we have 9 volts. It doesn't matter, the resistance that we put here, we will always have here 9 volts at this point. Of course, if the source is an ideal source. The current source, in the other hand, works almost the same, but for current. So we represent the current source like this. If we have a DC voltage current source, if we have an alternating current source, is not so common, but we can use like an arrow to one side and another one for the other side. But I will just keep as simple with one arrow. And basically it's like the voltage source, but now what we have is that it doesn't matter what is the voltage at the terminal, and more generally, we don't even know what is the voltage drop across a current source. But in that in this wire, we will always have the current that this current source supplies, right? So if it is a 10 amps current source, we will always have 10 amps in this circuit, right? And basically, these are the more common sources. We also have a thing called dependent sources. So what is a dependent source? It's a source that depends of the characteristics of other components of the circuit, or even some characteristics of the external the external world. For example, we can have a source that depends of the temperature, right? And that is good for building a thermometer, right? So we represent for voltage something like this. So this is a voltage. A voltage source which depends on other characteristics. For example, in the future we will learn about transistors, and we can represent transistors with a voltage dependent source, or more commonly with a voltage depending a current depending source, which the value is Gm times V pi, where Gm is just a constant and V pi is the voltage drop across the resistor called R pi. And basically this is what you just need to know for starting to learn about electronics, right? There are a bunch of sources, and you can try to learn the symbols. And basically, when you see a voltage source, you know that across that terminals, the voltage will increase or decrease depending on the polarity by that amount. And when you have a current source, which in reality it's hard to have, but in circuits it might appear to simplify some calculations. You know that in that branch of the circuit you will always have the same current. Okay, so with this we finished the first lesson about circuits, and I hope you guys enjoyed, and we see you in the next video.